Paper 2, question 5, 2020, was one of these kind of Venn diagram questions, conditional probability ones. A lot of times people would say they don't like these questions, but with enough practice you'll find it's the same thing over and over. And the great thing about them is they're unbelievably short. Two events A and B are such that the probability of A occurring is 3/4, the probability of A intersection B, which is A and B both occurring as a half. Find the probability that B occurs given that A has occurred. And that can sometimes be the bit that catches people that are unsure about what that part means, but it's the probability that event B occurs given that A has already occurred. Give your answer as a fraction in its simplest form. So here is the formula. The probability of B occurring given that A has occurred is the probability that both occur divided by the probability that A occurs. So the probability of B occurring given that A has occurred is the probability of A intersection B all over the probability of A. And of course we have those figures on the right. So it's going to be a half divided by 3/4, which is 2/3. It might surprise you to note that that's worth 15 marks. And given that the paper is only 300 marks, that's 5% of paper 2. It then says, part 2 says A union B is 11/12, and if we remember back from first year sets, that's just it's A or B or both is 11/12. So with a bit of maths we can figure out that this part here is 2/12, since 1/4 would be 3/12, 1/2 would be 6/12, and obviously 3 plus 6 is 9, plus the 2 gives you the 11. Of course we can simplify that down to 1/6. So it then asks us to investigate if the events A and B are independent of each other. So does one occurring have no impact on the other occurring? So the probability of B, which is the circle B, is our half plus 1/6. Add that together and it is 2/3. Now some people realize that means straight away that they are independent, because the probability of B occurring given that A has occurred is the same as the probability of B occurring, which means therefore that A occurring has no impact on the probability of B occurring. But most people will understand it this way, that we say if two events are independent, the probability of the first multiplied by the probability of the second is equal to the probability of the intersection. So the probability of A multiplied by the probability of B is 3/4 multiplied by 2/3, and that is equal to a half. And of course that is what we have in the intersection. So that's it. The events are independent. Done.